Today's video is part of a series of precompiles proposals for the Ethereum Virtual Machine, or EVM. A precompile is a native smart contract that lives at a known address. For example, the EC Recover precompile lives at address 1. The precompiles that the EVM implements now do not have an associated bytecode but are natively implemented in the Ethereum client in the language of that client. Today we are showing a demo of a precompile for the EVM itself. I have a dApp here with an interpret function exposed by this EVM precompile, which lives at this address. And we have a MetaMask connected to a local EVM-based blockchain, which runs a fork with an implementation of this EVM precompile. The interpret function receives the runtime bytecode of a smart contract, the input or call data, the gas limit, and the value in Wei. And it returns the result of the computation. So within the EVM, you can interpret EVM bytecode. And I have prepared here some EVM instructions that just read the first 32 bytes from the call data and return the value. And this is the runtime bytecode. And this is our call data. So if we run this bytecode with our debugger with this call data, we should get the same result as our input. And we can see it here. Let's try another value here, 66. And we have our result. Now let's take this runtime bytecode and this call data and call the interpret function. And we get our result. And I have added some logs here in the EVM interpreter precompile, so you can see the input that the precompile received. And first we have the function signature for the interpret function, and then the actual input, and then the final result that is returned. And let's also use another call data, and we get the result that we used as input here. So this is a simple example, but you can execute batches of transactions by making successive calls to the precompile and wrap them in a pure function that does not leave side effects in the blockchain state. Or you can use a delegate call approach to write the state changes to another contract. So with a relatively small implementation effort, this EVM precompile opens a large innovation space by making the EVM more flexible. Just by having this EVM interpreter inside the EVM as a precompile, you can have native and efficient mechanisms for layer 2 solutions like rollups. And you can open a new way of storing and executing smart contracts. You can add multiple types of EVMs to be tested in production without affecting the actual base layer. This was a short initial demo on this topic. More on these ideas in future videos. So you just saw an EVM interpreter precompile implemented in a fork of Evmos. On-chain but client native, available inside the EVM with maximum gas savings. And this system is better than testnets for testing because it can use the full mainnet global environment and the EVM itself. It should become the criterion for pre-production testing instead of trusting testnets or off-chain sources of truth. And we can have a standard source of truth, the same that will eventually interpret the contracts. A battery of tests can be run in a single call to imitate state change dependent transactions. A lot of future demos on this stack will follow.